All right, again, so stat first was, if you go to mode, you got to make sure your stat diagnostics is turned on. That's the first setting you have to make sure is on. That gives you the R squared. Then second, stat plot, hit enter on 1 and make sure your stat plot is on. Those two things have to be done before we do anything else, okay? And because you reset your calculator before you take your quiz, those two things are going to have to be done as soon as you're done resetting your calculator. So I'll remind you on Monday, but obviously when it comes time to your AP exam, nobody's in there to remind you. So make sure you know how to do it, okay? Sorry? Yeah, so you go second y equals, and it pulls up your stat plots. And you just need number 1 turned on. So if you hit enter on number 1, you need the blinky thing to be on. The rest of it you can leave how it is. Okay, now we need to enter the data. So I'm going to stat, the stat button, which is underneath the delete button, okay? You're going to stat, and you're going to edit. You're going to hit enter on edit. We have data in there from yesterday. Or from Wednesday. We need to clear out. Okay, if you did it Wednesday, you have data in there. So if you hit delete, it will actually delete list 1, which is wait, you have to reset your calculator, bring it back. But you're not going to hit it. I'm not going to show you where it is because you're not going to hit it. It will delete the whole column. We don't want to do that. We're just going to literally hit clear. So as you move, like enter, clear. Wait, I lied. Delete on, not on the L1, but on the actual number. So like don't go, if you go up to L2 and you hit delete, it's going to delete the whole column. We don't want to do that. So you want to go to the number and then you want to just like highlight it and then you go to DEL, delete, okay? If it's the same amount of data as before, you could also just literally type and it will overtake it. But our new data set, if it's not the same dimensions, then we want to clear it out. Stat is where the data is. You have to be practicing this. This is not an option. Let's go. To assume you could do this without practicing it is insanity. All right, now we're going to enter in that data, okay? So 1, 2, 3, 4, 5, 6 are our X's. I literally hit 1, enter, 2, enter, 3, enter, 4, enter, 5, enter, 6, enter. And I fill in all my X values. With me? Yes. Yeah. Now I'm going up and I'm going to go over to the L2, which is what I'm going to enter my Y values. This is 10, 6, 5, 5.5, 6, 11. So 10, enter, 6, enter, 5, enter, 5.5, enter, 6, enter, 11, enter. If this was a quiz or test, I would for sure double check those. Make sure you look at your X's and your Y's, make sure they're right, because if you mistype that, obviously it gives you the wrong information after this. So double check that they're right. Are we good till here? Yes? Now if I hit graph, my stuff from Wednesday's in there, plus my new stuff, okay? So the line was what we did for Wednesday. If I go to my Y equals, it's there. I want to clear that out. We haven't gotten the model for this one. And I get my little dots. Do you remember how to make it so that it zooms in on those little dots? We go to zoom, and we go to zoom stat, which is the 9th thing in the list. And it will zoom in to give you that perfect picture. What does the shape of this look like? It looks like it's a parabola, which looks like it's quadratic. So if I was to guess my regression, that would be the best guess. The other way to guess it is to do your R-squareds. To do those, we run the regression and we look at the R-squared. So if I didn't know what this looked like, because I could do the R-squared part without even having to look at the graph. So let's say you're given the data and we're at the end of the year and you're taking your AP exam and you're given the data and you're not sure if this is quadratic or if it's cubic, right? Then I would enter the data and I would look at the R-squareds, which I'll show you how to get to. But the closer the R-squared is to 1, the better the model. So if I was going to run to see, if I didn't know it was quadratic, and if I was going to run to see, well, any way you run it, you go to stat to run, and instead of picking edit, we go over to calc. And in this list is our options. Right now our options are linear, quadratic, and cubic, but we will add to that eventually. Okay? On the quiz review, it adds in quartic, which is to the 4th. So if I wanted to know what linear looks like, I literally hit lin reg. And I don't want to store it yet. I'm just seeing what the R-squared is. This R-squared is 0.1. Linear is bad. Remember, closer to 1, better. I go back to stat. I go to calc, I go to quadratic. I'm going to run it. R squared is 0.955. That's pretty good, okay? If this was on like an AP exam or a test or whatever, I'd literally be keeping notes. I'd literally write linear and what the R squared is, quadratic and what the R squared is. And then I'd go to stat and I'd go to edit and I'd go to cubic and I'd run it. And I'd also write down that R squared, which is 0.956. So which one's better? The cubic. Yeah.
Can you go back and review that?
Yep. Well, I'm going to redo it anyways because I want to store it. But every time you want to run the regression, so like what you could, and you could do it from the graph screen. You could do it from your y equals screen. You could do it from your list screen. It doesn't matter. But to get to it, I go stat. I go to calc. And then in this list is all your regs. So lin reg means linear regression. Quad reg means quadratic regression. Cubic reg means cubic regression. And quartic would be the quart reg, okay? This is another, like 8 is another lin reg, but the order switches. Like if you look, the B gets the X. It's confusing. Don't even use it. You don't need it, okay? And then we'll eventually get to log, which is the ln, and we'll eventually get to exponential, but not today. Today we're focusing on these 4. Lin, oops, I just hit the button. Linear, quadratic, cubic, and quartic, okay? Yeah.
So the R squared that you're talking about would be when you press calculate?
Yep, when you hit calculate, it will give you the A, the B, the C, or whatever, but it will also give you the R squared if you turned your stat diagnostics on. If you didn't turn your stat diagnostics on, you won't see it. You'll have picked quadratic, and it would have been wrong. Does that make sense?
Yeah, because mine doesn't show you R squared.
So you have to go to stat, go to mode, and go to stat diagnostic. Yours might be the one that doesn't have it, because some of them don't have it, but yours had it, and hers is the same. You should see stat diagnostic and stat wizard. Do you see it? Yeah. Turn it on. Yeah.
We're looking for the one that's closest to 1.
Correct. A 1 is a perfect model. If it said R squared equals 1, which usually doesn't happen on the calculator one,
If it's over 1.
it won't be. 1 is the square of the distance between them. So like every time a dot's over it or under it, that distance is R. R squared takes all those R's, squares them, which means it's always going to be positive, and adds them together. So what we need to do is get it as close to 1 as we possibly can. It's never going to go over 1 because it's distance. But and that's the one you would pick as the best one. So as of based on those R squareds, my quadratic was the best. I mean, my cubic one was the best one, right? So now I want to run that cubic one. So I'm going to go back. I'm on the stat menu. I went to calc, and I'm going to go up to cubic reg, and I'm going to hit enter. This time I want to store it because I'm not just finding this model. I'm going to do stuff with it. So I'm going to arrow down to where it says store reg EQ, and I'm storing the equation it's creating for me. I need to put where I want it to store it. We want to store it in Y1 because that's what graphs, right? So I'm going to do alpha trace, and there's my Y1. I'm going to put it next to store reg EQ, which means store the regression equation here. It's putting it where Y1 is. Yep. We ran the R squareds, and the R squared is better on cubic. So it looked quadratic, but the R squared was better on cubic. Closest to 1, right? Quadratic was like 0.995, and cubic was 0.956. You still with me? Yes? Okay, now we're going to calculate. So enter, enter, and it's going to calculate it for me. So it gives me the A, the B, the C, the D, and it gives me the format of the standard form to tell you where to put these values. I'm going to screenshot this because I want a picture of it. But also, I'm going to go to graph. Don't do this because you're going to lose your ABC. Don't do this yet. Okay, but if I go to graph, it's going to graph that model. And again, it's not perfect. If it was perfect, it would literally go through every single dot. Okay, it's not perfect. And notice it's cubic, but it looks like a parabola. That means that over on the left-hand side, it might be going up and then back down again. We don't know what it's looking. But in this set of data, this is what it looks like, and it's pretty close to the match. Does that make sense? You could chunk a piece of your cubic function, and it could look like a parabola. That's where it's tricky. We're good? Yes? Okay, so I'm going to go back. Now my y equals is where that's stored. So if I want to use it, which is going to be part of the question, it's going to say use the model to predict what might happen. I use the Y1 that's stored. If you use your rounded one, because you're going to get it, if you use that rounded one, it's less accurate. So I screenshot it. I'm going to bring it in. Okay, this is how I'm going to build my equation. So y equals, oh, the best model we said was cubic. The regression equation, and it could be f of x or it could be y. That one doesn't matter, but it's 0.028, because we round to the 3 decimal places, x to the third, plus 0.619 x squared, minus 5.337x, plus 14.5. We got it? 0.028 x to the third plus 0.619 x squared minus 5.337 x plus 14.5. And again, this is now rounded. So if when it asks you to predict f of 7.5, you plug the value in to your given equation, right? If I plug it in here and I plug it in here and I plug it in here, it's a little less accurate than if I use the one that's stored in the equation on the calculator, because on the calculator it kept all those decimals. This is where your calculator is smarter than we are. So if you plug it in, you will get an answer, and if this is an FRQ, they will give you both. They will give you the rounded, and they will give you, if you use your calculator. If it's multiple choice, only the calculator answer will be there. So just be aware, you might be a 1,000th off, which is fine. You pick the one that's closest to it, okay? So now we're gonna plug it in. Go back to the video. Okay, so now I wanna find f of 7.5. I'm gonna quit out of here. And I go alpha, trace. I get my y1 back because that's where I stored it. I open my parentheses, 7.5, close my parentheses, and hit enter. And the predicted value would be 21.010. And there's no units on this one. If there was units, like on the example we used on Wednesday, it was money, right? If there was units, I would make sure I recorded it. Questions on any of that process? Okay, so other things you could see based on this is what's the rate of change from f of, it could be like f of 10, rate of change. It would be rate of change from 7.5 to 10, something like that. So you'd have to find f of 10, and then you'd subtract from it f of 7.5, and then you put it over 10 minus 7.5, okay? So those things can be asked. The things that we've been asked about in the past with a y equals can be asked about in a regression. It just, you have to come up with the equation. We good so far? That is what your quiz is on. Here is data. Figure out which model is best. Find the model. Either use it to predict something or find the rate of change. Something like that will be asked on that. Yes? Good. Questions before we move on? Okay. So the two other topics that are in this section, which will be on your test but not on the quiz, are proportionality and inversely and directly. And it brings back in like piecewise functions for rate of change. So the first is, and this is like hopefully seems familiar, this is an Algebra 2 skill, but it's, God bless you. If two units or two variables are directly proportional or inversely proportional. So in both cases, we bring in a constant. This text uses k for your constant. It could be any value. It doesn't matter. Sometimes it's m, whatever. It's just a constant. And what you're going to do is based on the first part of your, what's going to get given to you is it will say this is directly proportional to this. So the this that comes first is what you said on one side of the equal sign, equals directly proportional says take that second thing and multiply it by a constant. We're going to use k. And then it will say, given this is this, you'll solve for your constant, and then you'll plug it back in to get a new equation. The second part, so directly is multiply. The second is if it's inversely proportional, and if it's inversely proportional, but you put your second mentioned variable under k, so you divide. And those questions will look something like this. It says the force in newtons exerted by a magnet on a metal object is inversely. So as soon as you see inversely, we know divide. Inversely proportional to the square of the distance in centimeters. If a magnet exerts 60 newtons on a metal object 2 centimeters away, what will the distance be? What will be the distance when the force is 10 newtons? So what are my two variables? Centimeters, which represents the distance, right? So it's the units is centimeters, but this is distance is one of the two variables. What's the other one? Or subjects? The force, right? So we've got force and we've got distance. And the force is inversely proportional to the square of the distance, not just to the distance. So if I make this F, and you get to decide, because it didn't tell you what it had to be, make it whatever variable you want. I'm going to make force F, and I'm going to make distance D, because it would be weird to make it anything else. And I would say force is, which means equals, directly or inversely proportional to the square distance. So inversely proportional, God bless you, says put it under K. And it's not just distance, it is distance squared. Good.
But how do you know it's inversely?
It literally says inversely. As soon as you see it, circle it, because that's something you could miss. It'll say directly or inversely. Yeah. All right, now plug in the information that it gives you for the first round. So first round it says that if the magnet exerts 60 newtons, that's your force, so 60 is my force, on a metal object 2 centimeters away, that's my distance. The K is the unknown. The distance is 2, so I square it, and then we're going to solve for K. So I'd get 60 equals K over 4, and I multiply by 4 on both sides, and I get K equals 240. Now I use that to come up with a model that works for any pairing. I say take this K and replace it. So F equals 240 over D squared. That's my model. And then it says, what will be the distance when force is 10 newtons? It could ask you either one. It could say, what's the distance when you're given this force? Or it could say, what's the force if given this distance? This time they gave us the force, so 10 is your F, and I'm looking for the distance. So 10 equals 240 over D squared, and then I want to solve this. I could cross multiply, I could multiply by the diameter. Either way, I'm moving the D squared to the other side. 10D squared would equal 240. Divide by 10, D squared equals 24. And then I'd square root. There's no such thing as a negative distance, so I keep it positive, even though normally those rules would be plus or minus, right? So I get D is the square root of 24. If this is without a calculator, then I will rewrite that as 2 root 6, because I'd have to at least break it down. If it's on the portion in which it's calculator, then I'll actually find the square root of 24 and round it, so 4.899. And what unit is my distance? Centimeters. Kumar. In the notes is bringing back your piecewise function, but in a real world scenario. So it says the following model tracks the amount of accumulated rain during a storm where X is the time in hours and F is the accumulation of water in inches. So according to this, between hours 0 and 2, it's growing at a rate, or accumulating at a rate of 1/2 X squared plus X. In between hours 2 and 4, it's consistent at 6 inches. And from 4 to 6, it's accumulating at a rate of X plus 4. So A says, find F of 4, and what does it mean in this context? What do we do with F of 4? Good. 4 is equal to X, or like it's in between X is greater than or equal to 4 or less than or equal to 6. Not the 6, because that's not what we're equal to. So I do 4 plus 4 and I get 8. And what does it mean in this context? That after or at the 4th hour or 4 hours, whatever it is, the accumulated water is 8 inches, right? Yeah, inches. Or after 4 hours, whatever it is. 4th hour, not hours. All right, then B says find the average rate of change from 3 to 5 hours. So we're going to find f of 5 minus f of 3 over 5 minus 3. So for 5, which one do I use? Top, middle, bottom? Bottom, because 5's in between 4 and 6. So f of 5 would be 5 plus 4, which is 9. And for 3, do I use top, middle, bottom? Middle. For middle, there's nothing to plug in. F of 3 is 6. Okay. And then I'd get 9 minus 6 over 5 minus 3, or 3 halves. Which you can leave like that. You can make this 1.5, whatever it is, but we're talking about real world scenario, so there's units here. So it is blank per blank, which is what? Inches per, good, hour is my time unit. Questions? Okay, so your quiz review is completely focused on the regression because that's what Monday's quiz will be.
Is Monday's quiz just the regression?
Yep. It is, you have the calculator the whole time. It is literally just regression. It's like, I don't even know, 4 or 5 questions based on the regression. That's it.
It's just 1.14.
It's only the first part of 1.14. Not the rate of, not the piecewise functions and not the inversely or,
1.13.
nope, just the calculator regression part. I know, we went